Okay, let's get started with the calculator paper warm-up. Now the good news is with paper 2 you get to use one of these. The bad news is that creates a number of places where you can make mistakes. Now the first thing you're going to need to check inside your exams, and typically all of the invigilators will tell you this before you start your actual exam, but you need to make sure that the calculator is set in degrees mode. You can check this by having a look at the top of your screen and you're looking for a little D that's highlighted. If it says R or if it says G, you've got a problem. Call the invigilator over and get them to change it for you. The other thing as well is that the calculator is great and will do a lot of the work for you, but that can sometimes lead to lost marks where you don't show working out that the calculator has done. You must write down all the steps in your working out. If it's a big 5-mark question and you've just put down a correct answer, you are not picking up all 5 marks. So write down every calculation that goes into the calculator. Might sound a bit obvious, but make sure you read each question really carefully. Underline the key parts in it and actually ask yourself, have you answered the question? Because often there'll be a question where the answer is either yes or no, and you need to do some working out to get there and to justify your answer, but lots of students will forget to actually answer what the question being asked is. And the other thing to ask yourself is, have you done enough to get all of the marks? So if it's a 5-mark question and you've just written down number 6, do you think that's going to be enough to get you all of the marks? And chances are it's probably not going to be. So have a look at how many marks the question is worth and make a judgment call on whether you think that your working out justifies 2, 3, 4, 5 marks. Okay, let's get started then. So the first thing to note on this is that it is 100 marks on the paper, just like your real exam, and it is 1 hour 45 minutes, which is 105 minutes. So working to exam pace, a 3-mark question should be taking you 3 minutes, a 5-mark question 5 minutes, and so on and so on. So let's start with question number 1. First of all, I'm going to underline this because where it says in figures, I need to actually write out what the number is there. So 8,347 looks like that. Then I'm going to underline this bit just so that I don't forget what it is it's asking me to do. So I need to write this number in words. So I have to write the whole thing out, 3,179. What is the value of the digit 4 in this number? Well, it's 1,000. A nice trick here is to read out the number in your head. So that number is 34,512. And when you hit the 4, that gives you a bit of a clue as to what value that digit takes. The next bit, we're going to need to round this to the nearest 100. So look at your hundreds column, and you can see that's where the 7 is found. And the 8 to the right of it tells you that that's going to round up. So to the nearest 100, this one is 4,800. Now I underlined the number 100 or the word 100 just because you don't want to accidentally round it to the nearest 1,000 or to the nearest 10. It just helps to keep you really focused on what it is you're actually rounding towards. Question 2. Pretty simple, these ones. You just need to write in the names of the shapes. So the first shape has 5 sides and it is a pentagon, and the other shape is a cylinder. I'd also have accepted circular prism, but cylinder seems to be the more common name for this one. Now for question 3a, to write 1/5 as a decimal, on my calculator I'm going to get that to help me. What I'm actually going to do is 1 divided by 5. So to work out what any fraction is as a decimal, I'm going to divide the top number by the bottom. So 1 divided by 5, 0.2, that's my answer. Same on part B. Again, just underline the decimal just so that you know what it is you're actually trying to give your answer as. You don't want to mistakenly give it as a fraction or a percentage. So to do this one, if I've got 7% on my calculator, I can divide that by 100 to get what this is as a decimal, which is 0.07. A common mistake here is to write 0.7, which is not 7%, it's 70%. So just be very, very careful with that. 3c, to calculate a quarter of 80, well, if I'm dividing something into quarters, that means I'm chopping it into 4 equal parts. So on my calculator, I would do the sum 80 divided by 4, which is 20. Now if this sum had have asked for 3 quarters, I would take that 20 and multiply it by 3. And I can work out any fraction of a number that way. But in this case, my answer is 20. Okay, so on to question number 4. Now there's quite a bit of information going on in this table. The first bit says which hotel is the most expensive. So again, I'm just going to underline that so that I know exactly what it is the question's asking for, and I don't accidentally put the least expensive or anything like that. So I'm going to look down the price column and I can see that Hotel D is the most expensive. Question B, which is the only hotel not to have an ensuite shower? And again, it's important to underline that so that you don't get mistaken. There's a lot of words and a lot of numbers in this table going on, so it's very important that I know I'm looking for not having an ensuite shower. So if I look down the column with the ensuite showers, I can see the only one there that doesn't have one is Hotel B. And Anna wants to stay in a hotel that has breakfast. Which one is the cheapest one she can stay in? Well, the answer to this is not Hotel A, which is the cheapest one, because it doesn't serve breakfast. So for this one, she's going to stay in Hotel B again. Question 5. Brian wants to cook a meal, and it says it will take him 25 minutes to cook the meal, and he needs it to be cooked at 5:15. What time should he start cooking? So for this one, what we're going to do is we're going to add and subtract units of time. Now this one's a little bit more complicated because we're kind of going back in time. So what I'm going to do is I'm going to do it in little chunks that make it easier for me. So if I start off with 5:15, and then rather than try and work out 25 minutes previous to that straight away, what I'm actually going to do is I'm going to go back 15 minutes, and that takes me to 5 o'clock. Now if I've already used up 15 minutes, that means I've got 10 minutes left to use, so I'm going to go back another 10 minutes, and that takes me to 4:50, which ends up being my answer. For part B, same sort of question, same setup, still taking him 25 minutes to cook this one. What time should he start cooking it if he wants it cooked for 5:30? Well, for this one I can actually jump back in one whole chunk of 25 minutes, and I end up with 5:05. If you do want to make this a little bit easier, what I would suggest is jumping back 20 minutes to 5:10, and then another 5 minutes to 5:05 to make up your total 25 minutes. But the answer to this one is 5:05. Okay, Chrissy buys 3 teas and a coffee. The price of a coffee is 42 pence, and in total she pays £1.59. How much does 1 tea cost? So to do this, I need to take the coffee out of the equation completely. So I'm going to take the total that she paid, and I'm going to subtract the coffee from it. This now gives me £1.17. £1.17 is the price for all 3 of the coffees, for all 3 of the teas, sorry. So assuming that they're all the same price, which they would be, I'm going to take my £1.17 and divide it by 3, which is going to give me 39 pence, which is the answer to question number 6. Okay, on to question number 7. Now this one's kind of a little bit difficult for me to show you because there's lots of different shapes that you can make. First thing I'm going to do is highlight isosceles triangle, because that's what I need to draw, and I'm going to draw my version of it, which looks like that, which is wonderful. But the key thing here is that they must have 2 sides and 2 internal angles which are the same length. So yours might well look a bit different to mine, but it needs to have 2 sides the same length. So use the squares on this to kind of help you and form a guide. For part B, I'm going to underline parallelogram just so I remember what shape it is I'm drawing. Now on this one, again, they can all look slightly different. So I've drawn this parallelogram, and the key thing here is that it must have 2 pairs of parallel sides, which is what mine does. Now again, yours is going to look slightly different, or maybe it matches mine, but it must have 2 pairs of parallel sides. Okay, question number 8. So we need to come up with a suitable diagram to display this data. Now you'll notice that for hockey there are 2 different categories, for football 2 different categories, and the same for netball. So what I need some kind of diagram that splits down my data into 2 different bits, so I can see the difference between males and females. So to do this, I'm going to use a dual bar chart, which is the same as a bar chart, follows all the same rules, but instead it's got 2 bars that are linked to each other. So what I'm going to do is I'm going to draw my axes on, and I'm going to use the whole of the space that they've given me. Really, really important to label what these axes are going to be. So in my case, the y-axis is going to be the frequency, and the x-axis is going to be the sport that these people are playing. Now, very, very common mistake is that people forget to label the frequency axis, so make sure you do that. Next thing you're going to need is a sensible scale going up on your frequency axes. I've decided to use 1 square is 1 person because the maximum number of people I've got is 10. So I can see that 10 squares will fit inside this one quite comfortably. And I didn't need to put 1, 2, 3, 4 all the way up to 10. So I've just gone 2, 4, 6, 8. But I've kept the same scale. Then down here at the sport one, I've got hockey, football and netball. So now all I'm going to do is I'm going to draw my bars in. Now it's very important that when you're drawing these in, your different bars cannot touch. But the bars that are linked, so for example hockey, the male and female hockey players can touch each other. Then I've got to have a gap because football is a completely separate thing. Males and females playing football can touch each other, that's fine, but then I need a gap, and then netball. Now the only thing that's missing from this is a key to show people which one is the males and which one is the females. So for my fourth mark, make sure you add in a key. Now I coloured mine red and black. In your exam I'd suggest you do one shaded and one unshaded. Okay, on to question number 9. So which city had the lowest minimum temperature, which I've just underlined so that I don't get it mixed up? Well, if I look at my table, I can see that all of the minimum temperatures are in their own column, and the smallest one there belongs to the city of Moscow. The difference between the minimum and maximum temperature for London, well, I can see that the lowest temperature was -2 and the maximum was 18. So the difference between them is 20 for this one. Common mistake is to throw in a negative sign somewhere. You don't need it. If you're working out the difference between two numbers, that is always positive. What is the difference between the maximum temperature in New York and the maximum temperature in Moscow? So again, I'm just going to underline the difference between so that I know exactly what I'm looking for. And I can see that the difference between the two temperatures is 17 degrees. Again, no negatives needed here whatsoever. A different city has a minimum temperature which is 5 degrees colder than London's minimum. So for this one, it's important to note that it's 5 degrees colder than London's minimum, which is -2. And the only city with a temperature 5 degrees less than that is, again, Moscow. Question number 10. So on this one, I can use my calculator for this, although it's not too hard for me to do myself. I'm going to take that input. The first step is to multiply it by 4 and then add 0.5. So when I put 3 in, I should get 12.5 out. When I put -2 in, I should get -7.5 come out of this. Now to work it backwards, going from an output to an input and working from right to left, all I'm going to do is when I hit that box, instead of adding and multiplying, I'm going to do the opposite and I'm going to subtract and divide. So the first one I'm going to do on this is 24.5, take away the 0.5, which is 24, and then divide it by 4, which means that I must have had an input there of 6. Question number 11. So the first thing I'm going to underline is the mean, just so that I don't get mixed up, because there's lots of different averages and somebody decided to make them all begin with the letter M. So mean is the one where you add them all up and divide by how many there are. So if I add them all up, I can see that there are 54, and I write in that calculation. Sometimes it's easy to just write the number 54 divided by 6, but show me where it came from. And then divided by 6 gives me the mean average, which is 9. Next one, to calculate the median. Again, I'm going to underline that just so that I keep really focused on what it is I'm looking for. Now, the median is where I put all the numbers in numerical order and I find the middle of them. So I'm going to take my numbers, put them in numerical order, and then I can start crossing off from both sides. Now, I get a bit of a problem here that if I cross the 6 and the 9 out, I've got no numbers left. So I need the number that's exactly halfway between these two. So to do that, I'm going to add them up, divide them by 2, and that gives me a median of 7.5. Okay, on to question number 12. These are usually pretty nice, easy marks. So the two shapes which are congruent, and if shapes are congruent, that means they're basically the same shape. One of them's probably been turned around, but they have the same measurements. So underline the congruent so that you keep focused on what it is you're looking for. And the two congruent shapes that I can see here are B and E. Okay, on to the next part, which bizarrely has called itself A as well. Write down the two shapes which are similar. Now, similar means that one shape is an enlargement of the other one. So have a look to see if you can find a shape that's twice as long or 3 times as long than another shape that's there. Hopefully you can see that the shape A has a side that's 2 squares by 3 squares, and shape F has a side that's 4 squares by 6 squares. So shape F is an enlargement. The two shapes are similar. Mathematical name of shape D, hopefully from what we did earlier you'll recognise this as an isosceles triangle. Okay, on to question number 13. So the cost of a driving lesson with Roger Brunt's driving school is £19.50. Well, that sounds important, so I'm going to underline that. However, there's a special deal that your first lesson costs just £15. I'm going to underline that as well because that can be quite easy to forget. Rodney books 5 lessons with Roger Brunt's driving school, and we want to know how much it will cost him. Well, Rodney books these 5 lessons, and I know that his first lesson will cost him £15, and his next 4 lessons will cost him £19.50. So what I'm going to do is £19.50 times 4, which is £78, but then you've got to remember Rodney's not a plonker. He got the special deal and got £15 for his first lesson. So add that on to give you a total price of £93. Cassandra booked some lessons with the same driving instructor, so all of the information in the above paragraph still works for Cassandra. However, this time I've told you that it costs her £229.50 in total, and I want to work out how many lessons she actually had. So I'm going to underline that because that's an important piece of information, and I'm going to underline this bit because that's the question I actually need to answer for this. So the first thing I'm going to do is I'm going to take away that freebie. Well, not a freebie, but I'm going to take away the discounted first lesson because that's just a bit of a red herring for me. That's different to the cost of all of the other lessons. So £229.50, take away 15 is £214.50. Again, don't be tempted to just tap this into your calculator and come up with the number 214.50 out of nowhere. Show me the calculation. Now I know that this is made up of a number of lessons, and each lesson costs £19.50. So what I'm going to do is I'm going to divide that by £19.50, and it gives me 11, which is the number of lessons that Cassandra must have had. Question 14. The cost of an apple is 35p and the cost of a banana is 40p. Write down the formula for the total cost of X apples and Y bananas. So if I'm buying X apples and each one costs 35p, well, that's a multiplication, and I would write that 35x. And if I'm buying Y bananas and each one costs 40, that's a multiplication, and I would write it as 40y. Now the total of this is going to be your total for your apples plus your total for the bananas, and don't forget that it needs to equal t because that's something it tells me in the question. Question 15. From the list of numbers above, write down a square number. So a square number is when a number has been multiplied by itself. It's whatever you end up with. Common square numbers 1, 4, 9, 16, 25, 36, etc, etc. I could go on. You really need to make sure that you know your first 10 at the very least square numbers. Hopefully you all can see that the square number here is the number 4. From the list of numbers above, write down a prime number. So prime numbers are numbers with exactly 2 factors, 1 and itself. So from this list there are actually 2, 3 and 5 both count. I've decided to go with the number 3. From the list of numbers above, write down a factor of 10. So a factor is something that divides into that number. So of this, I can see that the only number there that divides into 10 is 5. And from the list of numbers above, write down a multiple of 10. Multiple is a number in that times table. So a multiple of 10 would be 20, 30, 40, 50, etc. And I can see that 20 is my multiple of 10. Okay, let's have a look at question number 16. So this graph lets you convert between miles and kilometers. Notice that it only goes up to 6 miles or 9 kilometers, so it doesn't do a great amount of distance. Carl and Sam are long distance runners. Carl runs 15 miles, Sam 25 kilometers. So the first thing to notice is they run different amounts of distance, or measured in different ways. How much further does Sam run than Carl? So to do this, I'm going to need them talking the same language. I'm going to need them both in miles or both in kilometers. So I'm going to underline this bit because sometimes it's easy to forget what the question's actually asking for. And I'm going to have a look at Carl. Now he runs 15 miles, which isn't on my graph, but 5 miles is, and 15 is in the 5 times table. So if I read up from 5, I can see that 5 miles is 8 kilometers. And using that idea, I can scale it up. So I know that 5 miles is 8 kilometers, which means 10 miles is 16 kilometers, which means 15 miles is 24 kilometers. Now I know that Carl runs 24 kilometers compared to Sam's 25. So Sam runs 1 kilometer further than Carl. So for this one, we need to draw in the pattern, first of all. Hopefully you can see that each time there's kind of a block added on at the left, the right, and the top of this shape. So 3 blocks in total added on each time. So your pattern 4 should look like that. How many squares would be in pattern 7? Well, to do this, what I did was I wrote down the number of squares or the number of blocks in each pattern. So 1, 4, 7, and 10. And like I said earlier, you can see that this time there are 3 being added on every single time. And all I did was I carried on that numerical pattern until I reached number 7. So I worked out that in pattern 7 there would be 19 squares. How many squares would be in the nth pattern? Well, this is basically asking you what is the nth term for this sequence. So I've got a sequence which is 1, 4, 7, 10, and I need to know how many squares would be in the nth pattern. So I wrote my sequence down again, and I can see that it's going up in threes every time. So that tells me it's going to be 3n something, but it's not 3n because 3n looks exactly like the 3 times table. So a nice cheat for this is to take your pattern and just go back one space. So if I went all the way back 19, 16, 13, 10, 7, 4, 1, and then thought about what would come before the 1, I can see that it would be a negative 2. And the nice thing is I can just stick that negative 2 on the end of this. So the number of squares in my nth pattern is 3n minus 2. Exactly the same as if they'd have said, what is the nth term for this sequence? Question 18, a data collection sheet. So you need to draw yourself up a table, and it needs to have a couple of things which are quite important. So it needs to have a column that tells you about whatever it is you're collecting data about. It might be subject or favourite colour, favourite car. So if we go through the subjects, maths, English, science, PE and other, just in case there's any other ones. And I need a box that says tally, and I also need a column that says the frequency, just so that I can see really quickly how many people prefer maths, because we all know that's going to be the most favourite subject. Question 19. This is a substitution problem, and I'm going to use my calculator just so I don't make any mistakes. But what I'm going to do is take each part of this and do it separately. So to find the value of t when x is 5, first thing I'm going to do is 4 times x, which I know is 5. That gives me 20. Then the other part of this is 3 times y, but I know that y is negative 3, so that gives me negative 9. And then I'm going to add the two of them together, and that gives me an answer of 11. Same in part B, but this one's a little trickier because this time you're given a value of t and y, and you need to find out what x is. So all I'm going to do is I'm going to write my equation with those values substituted in. So t, or 33, equals 4x plus 3 lots of y, which I know is 7. 3 times 7 is 21. So this is now starting to look like a linear equation, which we're used to solving. I'd subtract 21 from both sides, divide both sides by 4, and I work out my value of x was 3 all along. Question 20. So to write down the number of faces, edges and vertices on this one, it's important that we know the distinction between them. So a face is something that I could slap on this shape, like a face really. So I could slap the triangles that are on the end. I could slap the rectangles that are kind of on the bottom and on the slanty bits as well. So in total I could slap 5 faces on this. Edges, there's something that I could run my finger along that if they were really sharp would cut it. So for example, there's a nice straight edge on the top of this shape. There are edges down the sides of each of the triangles on the front and back of the shape. So in total, when I add all of those up, there are 9 edges to this shape. And a vertice just means more than one corner, which is a posh word for vertex. All right. So I'm looking for the corners of this shape. These are things that if you got poked in the eye with it would hurt a lot more than a face. So I can see that there are 1, 2, 3 on the front of the shape and 1, 2, 3 on the back of the shape. So in total there are 6 vertices. And to draw a net of this prism, the way I always like to think about it is I start with whatever the base of that shape is. So I can see that the base is a rectangle. And then I think about, well, what if I unfolded the sides? What would that look like? So the sides both unfold, and they're both rectangles as well, and it ends up looking like that. And then I think, well, what about the front and the back? What shapes are they, and where would they fold down from? Well, they're both triangles, so they would fold down from there, and there's the net of my triangular prism. Okay, question number 21. Now I've underlined this bit because it's a massively common mistake that people will just work this out, maybe correctly, and then put the number 3. It is not about that whatsoever. You have to show me exactly what's on your calculator display, every single number that's there. So make sure when you do this one, you write the whole thing down. There is absolutely no rounding going on in this one. So I'm going to introduce you to a button on your calculator, which hopefully you've seen before, and it looks like that. It looks a bit like a computer, I guess, with a rectangle, a line, and then a rectangle underneath it. And this is on the left-hand side of your calculator, about 3/4 of the way up. This is a fraction button, and if you press this on your calculator, it will insert a line with 2 boxes above and below. And actually what this will allow you to do is to enter this exactly how it looks in your exam paper. So whilst you're on the top line, you can put a bracket, 1 plus 0.7 squared, close your bracket, times by 2, and then you have to press the cursor down to move it onto the bottom line, and then you can type in your 1 plus 0.04. When you do all of that correctly, hopefully, you should get this answer. Now again, just remember, this is not 2.9, this is not 3, this is not 2.87, this is the whole thing. Question 22. Jenna is going away on a holiday. She changes £400 into euros. While on holiday, she spends €480. When she returns, she changes whatever she had left back into pounds. And we need to know how much she ended up with. So let's underline this because that's important. She had £400 to begin with. And we're going to need to work out how much that actually is in euros. I want to know how much she took away with her on holiday. Now the problem is my graph doesn't go up to £400. So we're going to have to do something similar that we did on the graph with the miles and kilometres earlier. Now there's lots of different ways you could do this. I think the easiest one is to look at £40. Now £40 is €52. But I don't want £40. I need 400, which is 10 times bigger. So that tells me that £400 is €520. Now, while she was on holiday, she spent €480. So I can work out how much she actually came back with by doing a subtraction. And she came back with €40. Now, that one's a bit nicer because that does fit on my graph. So I can read across from €40 and I can work out that she came back with £30. Okay, number 23. So on this pie chart question, we need to know what fraction of students choose basketball. Well, I can see that basketball has given me a massive clue there because it's put the right angle sign right inside there. So I know that the fraction is 90, which is the right angle, out of 360. But I can do better than that because what they'll often say on exam questions is write this in its simplest form, which would be 1/4. Now your calculator will do this for you. Using the fraction button I just showed you, if you type in 90 over 360 and hit equals, it will give you 1/4. It will automatically simplify that for you. 23b, there are 27 students in the class. How many choose tennis? So what I'm going to do is I'm going to need the fraction of students that tennis represents. So to do that, I'm going to need to work out what that angle is inside tennis. Well, I know that 190 plus 90 is 280. That's by adding up football and basketball. And there's 360 degrees in the total pie chart, or in the total circle. So if I take those away from each other, that leaves me with 80 degrees. So tennis must be 80 out of 360. Then what I'm going to do with that fraction is I'm going to times it by the number of students, which is 27, and that gives me 6. 6 students chose tennis. Question 24. Now on this one, it's really important to remember that all probabilities add up to the number 1. Now often what they'll do is they'll give you 2 boxes that are missing, but they'll say that the 2 boxes must be the same. Okay, now in that case, all you would do is work out what the 2 boxes are together and divide it by 2. Luckily this one's nice and easy for us. So the probability that Winston wins is 0.4, that he loses is 0.15. If I add those together, it's 0.55. And then if I take that away from 1, it works out that the probability he draws is 0.45. Part B is a really common question, especially on a calculator paper. It's very, very easy to remember how you do this. You're going to take the probability of the event that the question is asking you, which in this case is 0.4, the probability of him doing a win, and you're going to multiply it by the number of times that he plays the game or does the test or whatever it might be in the question. So my sum on the calculator here, which again I'm going to write in, is 0.4 times 200. And I estimate that I would expect him to win 80 of these times. Question 25. To calculate the circumference of a circle with a diameter of 7, well, let's underline that because that's all my key information. Now I can remember that the circumference of a circle has something to do with this weird thing called pi, so I'm going to need to know how to get that up on my calculator. Now to do that, I'm going to need 2 buttons. I'm going to need my shift button, which is located in the top left just below the display, and I'm going to need the times 10 to the power of x button, which is right down at the bottom, sort of in the middle. Now hopefully you can see that on the times 10 to the power x button, there's a little pi symbol just up in the top left hand corner in yellow. Anything in yellow can only be accessed by using the shift button first. So when I need to use pi, I'm going to press shift and then this times 10 to the power x, and pi should appear. So I remember that the circumference of a circle is given by pi times the diameter. Well, the diameter is 7, so I'm going to do pi times 7. And that will give me 21.9911 and then a few bits after that. Now often the question will say to you, give your answer to one decimal place. So I'm just going to leave my answer as 22.0 centimeters. But make sure you pay attention in each particular question, whether they're asking for 1, 2 decimal places, 3 significant figures, and make sure you stick to that level of accuracy. Question 26. So 2 shops sell 2 different jars or bags of sweets with different amounts in, and they cost different amounts of money. We need to know which one is better value for money. Now you can get these on calculator, you can also get these on non-calculator. The difference is if you get these on a calculator paper, the numbers will look horrible, which hopefully they do. I think they look horrible. So the way that we're going to do this is the same way every single time, only on a calculator paper. We're going to divide the cost by the amount. So let's have a look at shop A. I'm going to take the cost, which is £1.30, divide it by the amount, which is 400 grams, and that tells me that it's 0.00325 pence for 1 gram of sweets. And if I look at shop B, again, I'm going to take the cost, which is £1.15, and divide it by the amount, which this time is 350, and it gives me 0.003285, and then a few bits after that, pence for 1 gram of sweets. Now, if I always do cost by amount, then I always pick the smallest one, because it's the cheapest for 1 gram or 1 kilogram or whatever it might be of your thing, which in this case is sweets. So I can see that shop A gives me the cheapest value for 1 gram. And make sure that you actually answer this question by telling me that it's shop A. It's not enough to just leave the calculations there and hope that the examiner has got time to work this out for himself. You've done all the hard work, make sure you answer the question. Okay, question 27. What I'm going to do on this one is underline the key phrases for each of the parts of this question. So in the first one it's expand, and that means where I take the brackets and expand them out by multiplying everything inside the brackets by whatever's on the outside. So 3 times x, 3x, and 3 times 7 is 21. Keyword here is factorized, and that's where I put brackets in by taking out a common factor. Now in this case there are no numbers which are common factors, so I'm going to take out an x from both of these terms, giving me x bracket x plus 8. Part 3 or part C here is a tricky linear equation to solve. I've got unknowns on both sides. So first of all I'm going to underline the solve bit so I know exactly what it is I'm trying to do here. Now the problem is that I've got 4x on the left, 2x on the right. So I need to get rid of one of them. And the rule is this: pick your smallest one, get rid of it. Now I'm not going to say add or subtract this or that, because sometimes you will need to do something different. So I'm just going to say pick your smallest one and deal with it, get rid of it. In this case the opposite of a positive 2x is to take it away. So I'm going to subtract 2x from both sides. That leaves me with 2x plus 7 equals 17. Now just be careful when you're doing this, because in class, if you're anything like my group, in class, very good at this, but sometimes when we get into exams we get a little bit carried away and we'll take the number of x's away from the number, and they are different things. I can't take away 2 x's from a number 7 or a 17. 2 x's can only be taken away from 4 x's because they've both got x's. So that leaves me with 2x plus 7 equals 17. Next thing I'm going to do is get rid of the plus 7 by doing the opposite, which is taking away 7 from both sides, divide both sides by 2, and it gives me the solution x equals 5. Notice how I've laid this out step by step by step, every step of the way. This is a 3-mark question, so I don't want to jeopardize any of those marks. Okay, last bit then. To simplify these, again, just underline it so I know what I'm doing. And when I've got 2 powers and I'm dividing them together, I subtract the 2 powers from one another. So 9 take away 3 is 6. M to the 9 divided by M to the 3 is M to the power of 6. Question 28. This scatter graph shows information about a car dealership, and I need to put 2 points on. Well, this is fairly easy, and I would hope not many of you would make a mistake here, even if you didn't get the other parts of this. So if a price is 4,000 and the age is 6, you need to plot that point, which goes around about there. And if the price is 5,500 and the age is 3 years, you need to plot that point, which goes around about there. Now, in the next part, use your scatter graph to estimate the price of a car which is 5 years old. This is a really easy place to drop a mark. Usually these things are worth 2 marks. The first mark is for putting one of these in. You must have a line of best fit. Now I know when I mark exam papers, I will not give the mark unless I can see a line of best fit, because I'm not convinced that you've shown me you know how to do this. So draw in the line of best fit. The other thing I'm going to do is I'm going to put lines on there to show the examiner, look, I read across from 5 years, I've read down to this price, I know what I'm doing. So if I read across from 5 years, hit my graph and go down, I estimate the price of a car which is 5 years old around about 4,200. The next part, describe the relationship between the price and age of the cars. Well, it's a negative correlation because it slopes downwards, and I could also say that the price decreases as the age of a car increases. Now whenever you get a question like this that's on real life things, just stop, take a second. Does it make sense what you've written? I've seen some terrible things, like the sale of hats and scarves and gloves goes up as the temperature goes up, and we know that that doesn't happen. So it's really important just to stop. Does what I've said make sense? And in this case, I think it does. If you buy a car, it's worth less in 10 years' time. Okay, nearly there. Question number 29. Wonderful. This is very wordy, so we're going to underline a lot of stuff here. The normal price of 1 litre of petrol is 96.9 pence. That seems important. Dave's Delivery Service is a business that has 4 vans. Okay, I'm going to need to remember that. Each van uses 35 litres of petrol a day and are in use for 6 days a week. Yep, definitely going to need that. And the last bit, Dave's company receives a reduction in the price of petrol of 15%. So, what I need to do for this one, and this is always the difficult bit I think with these, is where do you actually start? Well, the question says he believes his weekly petrol cost is less than £700. Well, let's work out how much petrol he uses in a week. That's a good place to start for this. So, litres in a week. I know each van uses 35 litres a day, and each van is in use for 6 days a week. So if I did 35 times 6, 210 litres is what one van uses in a week. Now you'll notice I also underlined because Dave's Delivery Service has 4 vans. So the company doesn't just use 210 because they've got 4 different vans doing this. So if I do 210 times 4, then it's 840 litres used in a week for all 4 vans. Well, that's pretty good. That's a good start for me. What if I worked out next how much this would cost? Without a reduction, just how much this would cost. So a normal cost per week. Well, if I'm using 840 litres, and I know each litre is worth 96.9p, then I know that in total it costs me 81,396 pence. Now you'll notice each step in my calculation I've put down what the units are. This helps me keep track of what each number actually means. For example, a common exam mistake here would be to say, well actually that's £81,000, which it's not. That's way too big. It's 81,396 pence. Next thing I'm going to do is I'm going to work out his discounted cost. So I know that he gets a discount of 15%. Now to do a percentages calculation on a calculator paper, it's very easy. All you're going to do is take your 15%, turn it into a decimal, which is 0.15, and then times the two numbers together. So 15% of 81,396 is 12,209.4 pence. Again, I've called it pence so that I don't lose track of what that means. And that's 15%. But this 15% is taken off the total price. So I now need to do a subtraction. And I work out that the discounted cost of this petrol is 69,186.6 pence. Okay, now I'm going to turn this into pounds. So that means I'm going to need to divide it by 100 because pennies are 1/100th of a pound. And that means that it's £691.866. Now I can't have 0.866 pennies, so I'm going to round this one up. to 87 pence. And a nice thing here is that Dave believes his weekly petrol cost is less than 700. So the answer is always going to be around about there. So I think I'm on the right track with this one. Very, very important though. For all my working out, for the fact that this question is 5 marks, there are only ever 2 possible answers. Yes or no. Is he correct? And in this case, the petrol cost is less than £700, so my answer is yes. Okay, well done for sitting through all of that. I hope you found it useful. I know it's been a bit of a beast in with maths today, but I think we're really, really hopeful that this will help you in your next mocks, and it's something we'll be looking to repeat if it works for your actual exams. Now, a couple of things to remember just before I shut up and leave you alone. Make sure your calculator is set in degrees mode. The very first thing you do as soon as you get your calculator, check it's got highlighted D on the top line of your display. If you're unsure, pop your hand up and ask. You must show all your working out. You'll notice that every step of my calculations in this paper, I did everything that I typed into the calculator on there. I didn't just write down a couple of numbers and then stick an answer in and hope to get 5 or 6 marks, because it's not going to happen. Make sure you read each question really carefully. Sounds silly, but if you get to a question that's kind of tough, and then maybe go back to it and read it fresh again, but this time you read it in a bit more depth, suddenly it's easy again. So make sure you read each question very, very carefully. Underline the key bits for every single question so that you are focused on exactly what it is you need to do. Ask yourself, have you actually answered it? If a question is, does Dave think that he's got enough money for all his cars? The answer is yes or no. You can do all the working out in the world, justify that answer, but you have to answer the question, yes or no. And make sure that what you've written down looks like it's enough to pick up all of the marks. If it's a 5-mark question and you've written the answer 72 with nothing to back that up, 72 might well be correct, but you are not picking up 5 marks for it. So don't lose marks on questions that you can do, would be my big advice from this. Okay, right, thank you for sitting through me and my croaky throat. I'm off for a strepsil. See you later.